But we're only going to talk systematically about something called solids of revolution. The idea here is this. Suppose you have some shape, some graph, which is maybe looks like this. And now I'm going to revolve it. This is the x-axis and this is the y-axis. In this case, I'm going to revolve it around the x-axis. If you do that, then the shape that you get is maybe like this. If I can draw it a little bit, it's maybe a football. All right, so that's the shape that you get if you take this piece of disk and you revolve it around. If you had made this copy underneath, it still would have been the same region. So we only pay attention to what's above the axis here. All right, so that's the basic idea. Now, I'm going to apply the method of slices to figure out the volume of such regions and give you a general formula and then apply it in a specific case. I want to take one little slice of this football. Maybe a football wouldn't work too well. Maybe we should go back to a loaf of bread. Anyway, the key point is that you never really have to draw a 3D picture. And 3D pictures are awful. They're very hard to deal with, and it's hard to visualize with them. And one of the reasons why we're dealing with solids of revolution is that we don't have as many visualization problems. So we're only going to deal with this, and then you have to imagine from the two-dimensional cross-section what the three-dimensional picture looks like. So we'll do a little bit of an exercise with the three-dimensional picture, but ultimately you should be getting used to drawing 2D diagrams always to depict the three-dimensional situation, since it's much harder to draw. The first step is to consider what this slice is over here, and again it's going to have width dx, and we're going to consider what it looks like over on the 3D picture. So it starts out being more or less like this, but then we're going to sweep it around. We're revolving around the x-axis, so it's spinning around this way. And if you take this and think of it as being on a hinge, which is down on the x-axis, it's going to swing down and swoop around and come back, swing around. And that traces out something over here, which I'm going to draw this way. It traces out a disk. All right? So it's hard for me to draw, and I'm not going to try too hard. Maybe I drew it more like a wheel, looking like a wheel. But anyway, it's this little flat disk here. And so the method that I'm describing for figuring out the volume is called the method of disks. This is going to be our first method.